What if traveling across the universe didn't take millions of years, but only a few minutes? What if space isn't what we think it is, but something we can fold? And what if 2 points, light years apart, are secretly connected by an invisible tunnel? These aren't science fiction ideas. They're real equations, real theories, real possibilities. Today, let's break the myth and uncover the science behind wormholes. A wormhole is a hypothetical tunnel connecting two separate points in spacetime. Think of space like a piece of paper. You can walk from point A to point B, or you can fold the paper and make them touch. That shortcut is a wormhole. Mathematically, it's called an Einstein-Rosen bridge, a solution that appears when you apply Einstein's general relativity equations to extremely curved spacetime. In 1935, Albert Einstein and physicist Nathan Rosen studied how extreme gravity bends spacetime. When solving Einstein's own field equations, they discovered something unusual. A bridge between two regions of spacetime naturally appears in the math. They didn't name it wormhole. That name came later in 1957 from physicists John Wheeler and Charles Misner. These weren't storytellers. They were the fathers of modern relativity, and they believed wormholes were mathematically possible. To understand how wormholes work, we have to understand gravity. Gravity is not just a force pulling objects. Gravity is curvature. When something extremely massive bends spacetime, the geometry can twist so much that two distant regions touch. Forming a tunnel, a wormhole has two mouths and a throat. But there's a problem. The moment a wormhole forms, it collapses instantly. Why? Because gravity pulls the tunnel shut faster than anything can travel through. So to keep a wormhole open, we need something that sounds impossible. Negative energy or exotic matter. A form of energy that pushes space apart instead of pulling it together. Quantum physics suggests tiny amounts of negative energy do exist. And if nature already creates small wormholes at quantum scales, then stabilizing one might not be impossible. So, is there proof? Not direct proof, but we have mathematical proof from relativity, stable solutions that predict wormholes can exist. And we have quantum-level hints. The Casimir effect shows a negative energy is real. Quantum foam, a concept from John Wheeler, suggests space-time at tiny scales constantly forms and destroys microscopic wormholes. New theories like ER equals EPR by Leonard Susskind and Juan Maldacena propose that entangled particles might be connected by tiny wormholes. So while we haven't seen a wormhole, the math, quantum physics, and theoretical models keep pointing in the same direction. Wormholes are possible. Now here's the real twist. If wormholes exist, they could connect not just places, but times. A wormhole mouth moving at high speed could experience time differently due to relativity. One side becomes older, the other remains young. That means a wormhole could theoretically allow time travel, not in movies, in the math right now. So the question isn't, are wormholes real? It is. If the universe already has shortcuts, what else are we missing? Would you enter a wormhole if one opened in front of you? Tell me in the comments.
Welcome to the universe beneath everything. Welcome to Beyond the Particles.